Hi everyone, welcome back. So we're at Analytics Building Blocks, and as I mentioned previously, we're going to look at two example projects. And the first one is a tool called Apollo, as a tool for exploring large graph data. And specifically, it uses machine learning and visualization together to help with the graph exploration. So the problem that it's trying to solve is that given a large graph, you want to find out what are the interesting things that the user may want to look at. So previously, you may have remember that having this kind of picture, we often call them the beautiful hairball. Actually, there are many more names for it. You can call it a Death Star. You can call them a spaghetti. So the key point here is that there's not a lot of things I can do about it other than admiring its beauty. So what can we do about it? How do we help people explore and understand these kind of large amount of data? So this is what Apollo was built for. So it's to help people find more relevant things, in this particular case, more relevant nodes to look at from the large graph data. So this is a toy example of what Apollo can do. Imagine you are looking at a citation network. Let's say you are students. You're trying to find related work to read about. And say your boss, your advisor tell you, hey, so here are two interesting papers you may want to read. So one is a human-computer interaction paper in orange or in yellow. And the other one is data mining paper in blue. And now off you go. So find out what other things you might want to look at. So where would you go? So intuitively, you may want to look at papers that are what I call close to the paper that you started at. So the very left and the very right paper. So why is that? Because when you're reading paper, often these papers have a section called related work or literature survey. And an edge here in this graph would be a citation. So that means a paper is a node, a citation is an edge. So if two papers are connected, that means one paper either cited the other or being cited by the other one, right? So what that means is that starting from your original paper, when you're reading its related work section and you see something that's interesting, you're essentially traversing this graph going to its neighbors. And then similarly, you can repeat the same process. You look at that neighboring paper, and now, again, you look at the related work section, and then you say, ah, this is also interesting. So that means the further and further you go, then the relevance may decrease gradually. But the closer and closer the paper is to your original one, the more relevant it is. So what that means is we can use a technique we call Gilbert Association. So that means things that are connected in the network are probably similar. So a vivid example would be to say, you say, I'm a bad guy, so Apollo is a bad guy, and if I know you, then, well, I'm sorry, then you are also a bad guy by association. So technically, the technique that we use is called belief propagation. We won't go a lot of details into it, but that is an approach that allows you to propagate this kind of interest or this relevance from the starting paper, in this case, the two starting paper in yellow and in blue, and then go to its neighbor, and so on. So the closer, more relevant. The further away, less relevant. So now I'm going to show you a quick demo of Apollo. So specifically, how Apollo helps people make sense of sense-making literature. Sense-making is a subfield in human-computer interaction and naturally interact quite a few areas, such as collaborative search, information management, or information visualization. So in the demo that you're going to see, this is actually what you're going to get in the end. So this is a graph visualization showing how these relevant areas or how these relevant papers in these areas related to what the user would want to explore. So in the video demo, we will only start with one example paper in the middle. So this is actually a seminal paper in black in the middle called the cost structure of sense making. So the seminal paper, and then look at how people make sense of information and what are the costs, what are the theory behind it. So in the demo, you're going to see, look at the data set from about 80,000 papers that we crawl from Google Scholar. So the node size here would be citation count. So larger the node, the more citation it has received. And the edges would be citations. So this is what we're going to get in the end. And in the beginning of the video, we'll only start with just one paper, as I said. This is how Apollo looks like. When you first launch Apollo, there's only one paper in the middle. If you click on it, then you will see its paper information. So in this case, it's a paper called the cost structure of sense making. At the bottom, you'll see all this information, such as the title, the authors, the citation count, this PDF, and so on. So this is exactly the same information that we see on Google Scholar. So in this demo, I'm going to cheat a little bit here because I'm familiar with the paper information. So if there's only one paper in the beginning, then on the right, what you will see is papers that either cited it or being cited by it. So here we'll only look at the paper title, but in practice, you will want to also look at the PDF as well. So just skimming the title, already see that, oh, there's one paper called Information Visualization. Another one is about search. So pretty general topic. So I just drag those into the view. And in addition, what I do is I will create a group for each of them. One is called search. And then the other called information visualization. So two things happen. One is that a color is automatically assigned to each of them. And then also the other thing is that these two papers now become, we call the starting paper of those two groups, the blue group and the red group. And what that also means that by running the algorithm, belief propagation in the background, now I can start to propagate this relevance or interest from these two starting nodes to its neighbors and their neighbors and so on. What that also means that I can actually get a ranking based on the relevance. So I just click on the blue group and then I say, show me the 10 most relevant papers for the blue group. And again, I can just skim the title here, and I see the first paper is indeed relevant. The second one actually also. So just looking at the paper title, I already know that it's about search as well. So I drag both of them into the blue group as well. So they became additional starting paper. So now I can go back to my original paper. And now I bring in papers that had directly cited it. So by default, by showing the 10 neighbors, they are ranked by citation count. So that means the size of those nodes. And since I have already the two groups created, the blue group and the red group, I can actually change the ordering. I can say, why not we sort by how relevant they are relative to the red group? By changing the order and skimming the title, again, I can see very quickly the first few are indeed relevant to information visualization. The second and third also are. So add them also to information visualization. So something you will see more apparent here is that not only are they added to the group, but now you also see that the color changed to the remaining nodes that we haven't added. In particular, in Apollo, we're using color saturation to denote how relevant a paper is for that group. So we will see that here in the vertical list of nodes, the second and the fourth nodes are actually more red or more saturated. What that means is Apollo tries to surface to the user the relevant information to say, hey, if you are busy, you may want to skip the first one or the third one. And we believe that the second and the fourth one are actually more relevant. So this is actually a very subtle and effective way, because not really changing how people would interact with Apollo. By going down the list, now I see another potential interesting paper. It's called Personal Information Management. And it's pretty general, so I think it's probably a group by itself. So I create a group for it. And similarly, now that became a starting paper, and I can ask for recommendation as well. So to recap, the way that Apollo works is the user will specify exemplars, or examples, as you saw. And then using the belief propagation in the background, is able to find other relevant nodes. So what did Apollo go through in terms of the building blocks? So we need to do data collection. Actually, Google Scholar doesn't provide any API, so that means we need to scrape Google Scholar very painfully. And because of the scraping, we also need to do cleaning as well. So a lot of things are missing from the HTML page on Google Scholar. Fortunately, we did not need to do integration. Everything was from Google Scholar. Our main focus there is on building the algorithm, finding which algorithm to use. So analytics, we do quite a lot, analysis. And also visualization, the tool that you just saw, interactive visualization tool. So we spend a lot of time on that as well. And because it's a research in the academic world, so we also write paper for it, and we gave talks, and now we're doing this lecture. So that's a presentation part. So we didn't get to do the dissemination. Usually that means releasing Apollo to the wild, but we're actively working on it. So we're trying to recreate Apollo as a web app, and I hope all of you will be able to use it soon. And if you want to know a lot more about the details of Apollo, this is the paper published at CHI 2011. This is on the web, so very easy to find. And you can see all the 10 pages details about what it does. So what we just look at is an example project called Apollo, and also look at how it goes through the different building blocks, which one it has skipped and which one it has focused on.